Hello and welcome to the Channel Academy. In today's video, we are going to calculate some trigonometric expression using the trigonometric circle as a tool and of course without using any calculating machine. So first expression, we've got a is equal to cos of minus 2018a minus cos of minus pi over 4 plus sinus of 3 pi over 4 minus sine of pi over 4. Let's call the different parts a1, this one A2, this one A3, and this one A4. This will be easier to treat. And let's create a trigonometric circle, of course. So we want a circle, big trigonometric circle with the cosinus axis here and the sinus axis here. So we've got the cosinus here and the sinus here. Let's write down the angles. So first, A1. We want to locate this angle. Here we can start by 0, doing one turn around, going to 2 pi, etc., until we get to 2018 pi, okay? Or we can go the other way and go from 0, do one turn around, go to minus 2 pi, one turn around minus 4 pi, until we go to minus 2018 pi, which is an odd multiple of pi that will be located, an even multiple of pi, because 8 is even, that will be located here. And so we know, because of the radius of a trigonometric circle, r is equal to 1. We know that the cosinus that can be read on this axis, will be equal here to 1. The cosinus is equal to plus the radius here, so it will be equal to 1. A1 is equal to 1. Now what about A2? You've got our angle minus pi over 4. So we start from 0 and we go minus pi over 4. We don't know so much about what happens in minus pi over 4, but we know what happens in pi over 4. We know that in pi over 4 we will have the cosinus that will be equal to square root of 2 over 2, and the sinus that will be equal to square root of 2 over 2 as well. Now what happens for minus pi over 4? We can see that we will have the same cosinus, because we read the cosinus on this axis and the point where we read is the same, but we will have an opposite sinus. Okay, so the sinus will be equal to minus square root of 2 over 2, because we've got the same length here and here, but we are on the negative part of the sinus. And so here we are looking for the cosinus. So the cosinus is equal to, let's read, square root of 2 over 2. Now for A3, we are looking for the sinus of 3 pi over 2. You've got here 0, so 0 pi over 2, 1 pi over 2, 2 pi over 2, and here 3 pi over 2. And we are looking for the sinus. We are in the negative part of the sinus, and we read the sinus here, and we know that the radius is 1. So we have the sinus, which is equal to minus 1, easily minus 1. Now for A4 is equal to the sinus of pi over 4. We have already answered the question. This is equal to square root of 2 over 2. And now we've got A, which is equal to A1 minus A2 plus A3 minus A4, which is equal to 1 minus square root of 2 over 2 plus 1 minus square root of 2 over 2, which is equal to 1 plus 1, 2. Let's put everything over 2. So we've got 4 over 2 minus 2 square root of 2. Let's simplify. We've got 2 minus square root of 2 is equal to a. We've got our first solution. Now for the second one. So we are going to call same thing here b1, here b2, here b3, and here b4. And we are going to sketch a beautiful trigonometric circle. Beautiful and large trigonometric circle with the cosinus axis here and the sinus axis here. Okay, we want to locate cosinus of pi over 6 first. We want to locate and then find its cosinus. This is a regular angle, you should know. Pi over 6, the cosinus is easily square root of 3 over 2. You have to know this one by heart, of course. b1 is equal to square root of 3 over 2. Same thing, sinus of pi over 3, you have to know it by heart, so this is equal to b2. You have to know it by heart. We've got our pi over 3, which is this angle, pi over 3, and the sinus will be equal to square root of 3 over 2 as well. So here we've got square root of 3 over 2. I do not do any demonstration because, of course, you need to know these angles. Same thing with sinus of pi over 2. Pi over 2 is located here, and its sinus, because we read the sinus on this axis, is sinus is equal to plus 1. So b3 is equal to plus 1. Because I do not go into details because you need to know these angles. So here we've got radius 1 and counting positively for this point. Then sinus of 4 pi over 3. So we count 1 pi over 3, 2 pi over 3, 3 pi over 3, and 4 pi over 3, which is somewhere here. 4 pi over 3. And what is interesting here is that if I do a little graph, okay, I will have the same length, let's call it capital L here, and with pi over 3. But this time I am counting it negatively for the sinus because we are in the negative part of the sinus. So b3, b4, which is sinus of pi over 3, will be equal to minus L. Minus L because we've got this length here, but counted negatively in comparison to pi over 3. So minus L, which is equal sinus of pi over 3, square root of 3 over 2, to minus square root of 3 over 2. And capital B is equal to b1 plus b2 minus b3 plus b4. And let's add everything. This is equal to square root of 3 over 2 plus square root of 3 over 2 plus minus 1 minus square root of 3 over 2. So this one can be simplified with this one, and we are left with square root of 3 minus 2 everything over 2. So you need to do some simplifications, of course, when you give your result. And now we have the result. So hope you enjoyed the video. See you soon. Bye.